All right, welcome. Today we are going to talk about section 5.7, talks about rational exponents. So one of the rules that we need to follow is basically taking a power that has a rational exponent, and changing it into an nth root. Okay, so just a couple examples here. Well, let's say that I had x to the 1/4 power. That'd be the same thing as saying the 4th root of x. Okay, so that's kind of an example there. Another one, let's say that it wasn't quite as neat there. What does the numerator of the exponent mean? Well, let's say that we had m to the 2/3 power. Well, the rule I always claim is that the denominator is your nth root, and the numerator is actually your power of the variable. So it's actually m squared, the cube root of m squared. So that's how the rules of rational exponents go. So kind of creative there. Some problems. Let's say that we had the 5th root of b, and I want to write it the other way, as a rational exponent. So, obviously, the power here is just b to the 1st, so it's just b to the 1/5. So, going back the other way, it's really not that hard as well. That's similar. Just remember that when you just take the square root of any particular variable, it's just x. There's a 2 here, we just don't ever show it, so it's x to the 1/2. Alright, so that's kind of important. A lot of people forget that. Evaluating expressions, so let's say that we had some numbers involved here. Oops. Let's say that we had 49 to the negative 1/2. First of all, one thing I would suggest that you do is try to make the negative exponent positive. And how would I end up doing this? So this equals 1/49 to the 1/2. So I make a fraction out of it. Okay, and what does 1/2? What does 1/2 mean then? How can I rewrite that? Instead of as a rational exponent, I could write it as a
root.
A root?
Yes.
So 1/2 corresponds with
the square root.
The square root of 49. Yeah.
Is it 49 squared? No, it's not. Sorry.
No, the denominator of the rational exponent is the nth root. So in this case, it's square root since it's a 2. Okay, so then I have 1 over 32 to the 2/5 power. 32 to the 2/5 power. So, first thing I would do is kind of rewrite it as in terms of symbols, notation. The 5th root, so it's the 5th root of 32 squared. So I'd be taking the 5th root of 1024.
Isn't it 2?
4.
4. All right. I'm just teasing. Let's go.
That's what
Alright.
I'm crying now.
2 more last ones here. Simplifying expressions. When you multiply powers, especially with the like bases, what are you supposed to do with the exponents?
Add.
Yes. Oh, good job. Add. All right. 1/7 plus 4/7 makes this easy to simplify, and you get y to the 5/7. That was Not very hard. So, with rational exponents, everything, all our other rules still apply. Okay? If you're multiplying with like bases, you add exponents. If we were dividing with like bases, you'd still subtract them, so on and so forth. Okay? So this is good here. Simplify this right here. Okay, so in this particular case, I go 1 over x to the 2/3.
And then you can
What does that actually mean then? That means I have 1 over
I know.
um,
It's
root of
the
x
cubic root
the
of
cube
x
root
to
of
the
x
second.
squared. Now, can I have an nth root?
No.
Being simplified, can I have an nth root, any kind of nth root in the denominator?
No.
No, I need to get rid of that.
Yes.
So how can I make the x squared a perfect cube root?
You have to multiply the for what is in the bottom.
So if I
No,
multiply
but-
this
No.
and this, what do I end up getting?
X cubed root of x
I get-
cubed.
Exactly right. And what would that be?
X.
X. Agreed?
Hey, you have to multiply on top too. Why can? Okay, guys, I got it.
And so therefore, if I wanted to change this back into rational exponents, I could actually say that
Say.
oh no, I went off the screen. What shall I do?
I think you should just erase that and put it in the bottom. Or do that.
So the first one, I want to simplify it. I need to kind of get rid of the nth root at the bottom. I think one of the things I would probably suggest doing here is actually changing this to rational exponents here. Makes it a little bit easier to handle, to solve. So, and then what I would actually do is try to make everything with the same base. So if you guys are paying attention here, 16 as a power of 2, or a base with base 2, I can actually rewrite 16 to what? 2, is it 2 to the 4th? 2 to the 4th is 16, right?
Yeah.
So rather than writing 16, I'm going to say 2 to the 4th to the 6th divided by 2 to the 1/3. And then a power of a power, what do we do? Multiply. Power of power, you multiply. Exponents. I get 4 times 1/6, which is 4/6, which is actually 2/3. And then 2 divided by 1. What do we do when we divide? Now we have like bases, correct?
Yeah.
Now I can actually use my rules. What do I come up with there then?
2 and 1/3.
Yeah, I mean, I subtract my exponents, correct? It's 2 2/3 minus 1/3. It's actually 2 1/3 is my final answer. Okay? Now, is that the only possible way of going about solving that or simplifying that? Probably not. There's probably other routes you could have taken. So if you would have taken another route, don't think that there's only one way of going about getting the right answer. Okay? Similarly, with the next one, I want to simplify it as well. So I have the 6th root of 4x to the 4th. So my suggestion here is that we split this up. I get 4. It'll be 4 to the 1/6 times. Will be x to the 4th to the 1/6. I'm sorry. Let's. I always try to rewrite it as lowest power as possible. So if I write 4 as a power of 2 again, what would I end up getting there? 2 squared to the 1/6 times power of a power on this factor here. I get x to the 4/6, which is 2/3. What do I get? Simplifying down now, I get 2 power to power here. I get 2 to the 2/6, which is 1/3. 2 to the 1/3 times x to the 2/3. And well, I think that's all the further we can go with that. So, well, I guess if we're, if we're cube rooting everything here, I think what we could write this as 3, the cube root of 2x squared. So if we have the same cube root, I can write the factors underneath as 2x squared as the cube root of, the cube root of 2x squared. So that would be my final answer.